Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
How de Broglie's waves changed the world, the quantum revolution you didn't see coming. Today, we're not talking about just any physicist. No, today we're talking about the guy who made the world, literally wave. Yep, you guessed it, Louis de Broglie, the genius behind wave-particle duality. Think waves are only for water. Think again. This guy made the entire material world ripple. Let's see how he pulled it off. Picture this: you're a young physics student, fresh on the scene, and you suddenly shout to the universe, "Hey, matter isn't just particles, it can act like waves too." Most people would probably think you're off your rocker. But that's exactly what de Broglie did. He straight up challenged the foundations of classical physics. Back then, physicists were still peering at the world through the magnifying glass of classical mechanics. Along comes de Broglie with a quantum telescope and says, "You're looking at it all wrong." He shook the very ground beneath classical physics. Can you imagine the reaction? People probably thought, this kid's either had one too many glasses of wine or hit his head on the door, matter behaving like light waves? That's straight out of a sci-fi novel. But de Broglie didn't care. He didn't even blink. And sure enough, his discovery didn't just tweak physics, it left a permanent mark on the history of science. So how did he get there? Let's start at home. De Broglie was born into French nobility. Sounds fancy, right? Imagine this: his family didn't host physics seminars, they threw elegant soirees filled with art, philosophy, and politics. Dear Louis, is Einstein coming to dinner? Nope, not even close. Instead, they held what you might call highbrow literary soirees, where everyone debated history, literature, and political philosophy. Perfect environment to raise an artsy poet, maybe not exactly the breeding ground for a physics prodigy. Yet young de Broglie fell in love with literature. His father's influence shaped the way he thought. Over dinner, they'd discuss Shakespeare; over drinks, Voltaire. All this culture didn't just make him refined, it gave him a mind that could break the rules, think differently, see patterns where no one else did. You can probably picture it: steeped in literature and the arts, he still chose physics. When he stood at the crossroads of science, he didn't take the safe route. He ventured into completely uncharted territory, and that leap led to the invention of matter waves. Despite the literary upbringing, de Broglie dropped the pen for the particle and dove headfirst into physics. It all began at the University of Paris, where the hardcore world of physics grabbed his imagination. And he wasn't chatting with Shakespeare or Voltaire anymore, his classmates were Albert Einstein and Niels Bohr. But he wasn't intimidated. He forged ahead, building his theory and staking his claim on the physics stage. Why would someone raised in literature choose the chaotic, mind-bending world of physics? Maybe it was the thrill, the challenge, the unknown. Just like his later work shocked the physics community, he craved the big leap, the theory that would rock the very foundations of reality. So how did de Broglie come up with the bold idea of linking matter and waves? Are you ready for the next ripple? Before we dive into his wave-filled world, we need to understand that spark of inspiration. What seemed like a casual insight ended up transforming the face of quantum physics and shaping the universe we see today, full of waves and entanglement. De Broglie's world is one where breaking the rules isn't scary and being crazy is just part of the job. And this story? Buckle up. It's the tale of how one man shook physics to its core and dropped the matter wave bomb. Now, how did he jump from literature to quantum physics? This wasn't a casual career change, it was like a rock star crossing over into the world of science. Picture the 1920s, the physics world was obsessed with classical particles, light, and electrons. Then de Broglie jumps out, eyes sparkling, and says, "What if these particles are waves too?" Sounds like sci-fi, right? But that was the revolution he brought. It's like telling everyone, hey, matter isn't just hard, solid particles, it can ripple like water. How did people react? Louis, cut it out. Maybe you've had a little too much wine at the family dinner. Yep, many physicists thought he was joking. Science back then was pretty conservative: matter is matter, waves are waves, never the twain shall meet. But de Broglie had other plans. His matter wave theory ripped a hole right through the old physics framework. Boom, a literal shockwave for the physicists of the day. So, how did he come up with this bombshell idea? His academic background was anything but simple. Raised in literature, sure, but at the University of Paris, he met physics head-on. While others debated how electrons spin, de Broglie asked, why should wave behavior be only for light? What if matter has waves too? Maybe particles and waves shouldn't be separate. He made a bold claim: matter can behave like light, it has wave properties. At first, nobody threw a ticker tape parade. Many doubted him. Physicists looked at him like he'd lost it. Matter as a wave? Interference patterns? Impossible. But he held his ground, knowing that merging particles and waves would open entirely new perspectives. Sure, the onlookers weren't impressed yet, but this theory would one day transform science in ways no one could have imagined. And now, the piece de resistance, wave-particle duality. Imagine standing at a crossroads, and a scientist walks up and says, light is both a particle and a wave. You'd probably think, this guy's nuts, until he adds, and matter can do it too. Wait, aren't we in a sci-fi movie? Nope, that's de Broglie. He didn't just break physics tradition, he pulled matter from the particle club into the wave world. Wave-particle duality is one of de Broglie's most revolutionary ideas. Simply put, all matter, light, electrons, whatever, has a double life. Sometimes a wave, sometimes a particle. Even your trash bin outside? It has wave potential. Okay, maybe not literally, but that's the kind of reach de Broglie's theory had. Why does this matter? His ideas laid the foundation for quantum mechanics. Electron behavior couldn't just be explained as particles moving on fixed orbits. De Broglie's waves meant electrons could spread, interfere, and diffract. Suddenly, the world of quantum physics was no longer a simple particle playground. His duality inspired Schrödinger's wave equation, Heisenberg's uncertainty principle, and the quantum revolution that followed. Without de Broglie, we might not have quantum computing, quantum communication, or lasers. Basically, your smartphone, TV, and high-tech medical devices all owe a nod to him. So, next time you swipe your phone or scan in at a hospital, remember, de Broglie's waves are quietly doing the heavy lifting. Science isn't just numbers, it's magic hiding in plain sight. As the English say, fortune favors the bold. De Broglie dared to break the rules and the world gained a quantum revolution. You might not realize this, but de Broglie's idea didn't just tweak physics, it flipped it on its head. From electrons to photons, his wave-particle duality continues to shape how we understand the material world. If quantum mechanics feels like magic, and you can't wrap your head around electrons suddenly playing hide-and-seek between particle and wave, think of it this way: it's like a Transformer movie, but in physics, and de Broglie is the guy pulling the levers, turning robots into new shapes. Funny thing is, when he first proposed this, the physics community didn't exactly throw a ticker tape parade. People probably thought he'd had one too many cups of coffee. But a few years down the road, Heisenberg and Schrödinger jumped into the quantum shapeshifting game, and suddenly the entire field went wild. They weren't playing video games, they were rewriting the rules of reality. That's de Broglie's charm. What seemed like a crazy idea at first became the foundation of modern physics. Think about it, when de Broglie introduced wave-particle duality, Bohr's atomic model was still the rock star of physics. But Bohr's model had a little hiccup: it couldn't explain why electrons didn't just plummet into the nucleus. Picture yourself as an electron. Oops, one misstep and you'd fall right into the atomic center. Bohr's model was brilliant, but it didn't answer the million-dollar question: why doesn't that happen? Enter de Broglie. His theory gave quantum mechanics a fresh perspective. Electrons weren't just particles, they were also waves, spreading out, creating interference patterns, forming what we now call probability clouds. Imagine looking for your keys in the dark. You know they're somewhere in the living room, but tracking them feels like chasing a ghost. That's your electron. And it didn't stop there. Heisenberg took inspiration from de Broglie's waves and dropped his uncertainty principle bomb: you can't know both a particle's exact position and momentum at the same time. In other words, you can never pin down an electron completely. It's like trying to nail down a cat that keeps slipping through your fingers, except the cat is an electron, and the stakes are slightly higher. Meanwhile, Schrödinger got busy too. Using de Broglie's wave idea, he gave electrons a wave function, his famous Schrödinger equation, mapping out where electrons might be. Think of it as a GPS for electrons, but instead of precise coordinates, it's a cloud of probabilities, maybe here, maybe there, maybe everywhere in between. Suddenly, physics had gone from black and white certainty to a world painted in shades of quantum gray. As these ideas took hold, the entire physics scene transformed. The tiniest particles weren't just little billiard balls bouncing around anymore, they could behave like waves, too. It's like going to a movie and realizing the characters can not only walk but also fly. The microscopic world turned out to be far stranger and far more beautiful than anyone imagined. Every quantum breakthrough since then has been another punch to classical physics, shaking it to its core. And wave-particle duality isn't just theoretical, it's practical. Modern tech owes a huge debt to de Broglie. Quantum computers, quantum communication, lasers, all of it traces back to his insight. Quantum computers exploit superposition and entanglement, phenomena directly tied to de Broglie's matter waves. You don't want your quantum computer stuck doing simple binary math, it can do things that would make your head spin. Quantum communication? That's leveraging entanglement, the spooky action that de Broglie helped us understand, to send messages that are nearly impossible to hack. So next time you're on a video call or crunching data on a supercomputer, remember, de Broglie's waves are quietly working behind the scenes. Science isn't just equations, it's magic hiding in plain sight. As the English like to say, fortune favors the bold. De Broglie dared to challenge convention, and the world got a quantum revolution. And here's the cherry on top, de Broglie wasn't just a science nerd. He was a true French aristocrat, a man of letters, a connoisseur of art and philosophy. His life wasn't all formulas and equations. Imagine dinner at his house. Between courses, you might discuss quantum mechanics, then poetry, then Parisian art trends, all in the same breath. He might say, "Ah yes, the electron's wave function is fascinating, but did you know Hamlet could be interpreted through quantum theory?" De Broglie's upbringing was anything but cold or rigid. Growing up in a French noble household, walls adorned with art, windows opening to Paris, conversations spanning politics, literature, philosophy, and science, that environment shaped his mind. He didn't just read books, he absorbed ideas, debated them, synthesized them. That broad perspective let him cross the boundary from literature to physics with ease, seeing connections others didn't. It's no wonder he dared to ask the questions everyone else thought were crazy. Literature taught him to think, art taught him to imagine, and physics gave him the tools to change the world. From aristocratic salons to the quantum frontier, de Broglie's life was a fusion of culture and science, and his wave-particle duality? That was his gift to the universe. Even though de Broglie grew up surrounded by art, poetry, and philosophy, he didn't just linger in discussions about Shakespeare and physics. No, he boldly decided to push the boundaries of science. His upbringing shaped him, sure, but in the end, he'd have headfirst into the world of physics, a universe packed with equations, theorems, and endless curiosity about the hidden rhythms of matter. Imagine if he'd stayed in his family's artistic salons, maybe we'd remember him as a poet-physicist scribbling sonnets about electrons, rather than the revolutionary mind who reshaped quantum mechanics. In the scientific world, de Broglie wasn't just a thinker sitting in his office. He had close ties with other big names of his time: Einstein, Bohr, and the like. Picture him in a room with Einstein, hashing out ideas. This wasn't dry math homework, it was philosophy, theory, and imagination crashing together. Einstein, the cosmic uncle, laid out relativity, and de Broglie, the quantum prodigy, countered with wave-particle duality. Sparks flew. Ideas collided. Minds expanded. These conversations weren't just your theory versus mine. They were battles of thought that propelled physics forward. De Broglie, young but daring, didn't stick to the old frameworks. He challenged established ideas and proposed his own bold hypotheses. That fearless mindset, combined with exchanges with giants like Einstein, injected new energy into the field. And though his matter wave theory wasn't instantly embraced, those debates gave him drive, inspiration, and perspective. Without them, quantum mechanics might have progressed more slowly or missed key insights entirely. But here's the thing: despite all his groundbreaking achievements, de Broglie's personal life was full of warmth and stories. He wasn't a cold, detached scholar obsessed only with formulas. Far from it. He loved to travel, loved spending time with family and friends. As a nobleman, he had a way of seeing the humor in life, turning even mundane moments into moments of elegance and charm. That balance between intellect and humanity may well have helped him stay calm in the face of physics' most turbulent waves. His emotional life might be less famous than his science, but it was rich. Letters and family interactions reveal a man who wasn't a rigid academic recluse. De Broglie was the quintessential French gentleman, thoughtful, idealistic, warm, and witty. He could navigate the abstract labyrinths of physics, yet also engage with family and friends in lively, personal ways. He didn't isolate himself from the world. He loved friends, lively discussions, debates, whether about quantum quarks or Parisian culture. That curiosity, that openness, let him carve out his own space in science, blending the intellectual with the cultural. If you think de Broglie was only about formulas and labs, think again. He was fascinating, full of poetry and art, and that artistic sensibility fed his scientific creativity. And let's not forget the real impact of his ideas. De Broglie's matter wave theory didn't just change physics, it laid the foundation for the technological revolutions we enjoy today. Quantum computing, modern communications, lasers, all of it traces back to him. Think about it, you might be sitting on a comfy couch scrolling your phone, sending texts, watching videos, playing games, and de Broglie's waves are quietly at work behind the scenes. Next time you unlock your phone, maybe one of his electrons is winking at you, "Hey, I'm still here." His influence is bigger than most realize. His theory caused waves in quantum mechanics and fueled the tech that drives our society forward. Quantum computers, quantum encryption, even lasers, these are not sci-fi dreams, they're rooted in de Broglie's insights. Matter is both particle and wave, and that duality underpins quantum computing. Imagine computers not as mere switches but as quantum brains handling mountains of information at lightning speed. It sounds like magic, but that's the gift he left us. Quantum communication is another triumph. Nearly unbreakable encryption is possible because of the principles de Broglie unveiled. The waves of matter and light he described gave scientists the tools to make our information more secure than ever. Every time you send a message with confidence, remember, de Broglie's wave is there, keeping it safe. And lasers, think about it. From scanning barcodes to performing precise surgery, lasers touch every corner of life. The roots of this technology trace back to his matter wave ideas. He couldn't have predicted the laser revolution, but he laid the groundwork. When de Broglie won the Nobel Prize, it wasn't just a personal accolade, it was recognition of his pivotal role in advancing science. His work inspired generations of physicists, and his ideas continue to influence computing, communications, medicine, and more. Modern technology stands on the shoulders of his waves. Without de Broglie, quantum physics and the technologies it fuels might have evolved far slower. From a young nobleman to the master of wave-particle duality, de Broglie's journey is a story of boldness and innovation. Do you now see what his matter waves really mean? He made the world ripple with new possibilities. He dared to question the foundations of physics and revealed a quantum universe unlike anything anyone had imagined. Every time you unlock your phone, boot a computer, or use technology, de Broglie's waves are at work. So next time you think about an electron, give it a big wave of appreciation, because de Broglie showed us its other side.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.